Hello friends, how are you? Welcome to Daskom Laboratory. This time my friends and I will be explaining Module 8, namely Searching. Let me introduce myself. My name is Givani Farahia with the assistant code GIP. The first practical objectives. Number 1, you understand and comprehend search logic using sequential and binary methods. Number 2, be able to implement search logic into a program using the C language. Next, what is the searching algorithm? Searching algorithm, one of the most common processing in programming is data retrieval. While searching, search algorithms are used to find the location and procession of a specific element within a dataset. In this module, we'll learn two basic search algorithms. Number 1, sequential search and binary search.
So, hello everyone, my name is Azara Kesha with my code assistant is KEY. So, this time I'm gonna explain about sequential search. Okay, what's sequential search? Sequential search is a method of searching for data by checking each element one by one from the beginning until the desired data is found, or until all elements have been checked. It is similar to searching for someone in a crowd, where we look at the face or body shapes of each person until we find the person we are looking for. So the next one is gonna explain by my friends. Thank you.
Okay, here I want to explain about the principle of sequential search. First of all, let me introduce myself. My name is Nailadi Hanifa. With assistant code is NOY or NOY. So sequential search is basically a very simple searching method. The idea is that we check each element one by one, from beginning until we find the data we are looking for. You can imagine it like checking your class attendance list from the top until you find your friend name with a random alphabet. One thing you should remember is that sequential search is a bit different from binary search. Binary search requires the data to be sorted first, while sequential search does not need any sorting. It just checks directly from the start to the end. Now let's see an example. We have an array 2, 4, 0, 1, and 9, and we want to find the number 1. First, we start from index 0, which is the number 2, since 2 is not 1, and we move to the next. At index 1, we find 4, but 4 still not the number we want. So we continue again and again until we finally find the number we want. At index 3, we find the number 1. That is exactly the data we are searching for. Once for data is found, the search stop immediately. But if we go through the whole array and still can't find it, that means the data simply does not exist in the array. So the conclusion is sequential search is simple, like check one by one until you find it. So, next.
Okay, let me introduce myself. My name is Mahali Farhamina Pinsi with the assistant code VIP. Now I will explain the example of sequential search program. At the beginning, the program includes standard input or output library. It can use functions like printf and scanf. Next, in line 3, there are main functions. Inside main function, there are several variables are declared, such as a loop counter and to store the number of data, search to hold the value the users want to find, IDX as an index used during search, and last, A is an array to store up to 100 integers. The program first asks user to enter how many number of data that they want to input. The number of data is stored in the variable n. Next, use for loop. Program as user to input each number and store into array. After the all numbers are entered, program as user to enter the number that they want to search. The number that they want to search is stored in the variable search. Next, program performs sequential search. Start with the first element and compares each number by search value one by one until the value is found or until the end if the value is not found. Finally, program will check the result of the search. If the data is not found, program will display data not found. But if data is found, program will display data found at index blah 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 to show the position of number in the array. Like this one. First, we enter the number of data, for example 5. Then, we enter each number and store into the array. Data number 1, for example 5. Data number 2, 7. Data number 3, 9. Data number 4, 3. And last, data number 5 is 1. After the old numbers are entered, we enter the number that we want to search, for example 7. Because the number is found, program display data found at index 1. As we can see, even though we keep 7 in data number 2, the array is still be number 1. Why? Because we must remember that array start from 0. That's all. Next will be explained by my friends.
Hi everyone, I'm Miss Rina Ali and my assistant code is LYN, and I will explain to you a flowchart of the sequential search. So after the program start, as usual, we have to declare the variable that we need. In this case is I and search IDX and A. And after that, we can input the amount of data that we want to share, and after that there will be a decision. If you can see this flowchart, this part is the looping part, which will make you enter the number of each data, and then after that there will be another input that you can use to enter the number that you want to reach for, that you want to search for, and then the program will start the sorting and the searching program. So the program will set the IDX equals to 0, and there will be a decision: is IDX is below n? If true, there will be another decision: is the value of the a variable at the position of I is the same as the one that we're searching for? If yes, that means the data is already found, and then the program will show to you that data found in the IDX variable, and the program will end. But if it's not, then the program will set the IDX equals to IDX plus 1, and then it will continue to the first decision, and then it will start over again. But if on this decision is false, then the data means it's not found. Okay.
Hello, my name is Oktariski Leila Ramadhani with assistant code is OKY. Next, I will explain about binary search. What is binary search? Binary search is typically used for large data sets. This kind of search method involves sorting the data first. In array, binary search has 3 indexes. First is low, initialize with 0. Second is high, initialize with n minus 1. And third is mid, calculated by formula low plus high divided by 2.
Hello guys, let me introduce myself. I am Shifa Khairisa with assistant code KHR. So, I want to explain about the example of binary search process. Now, the first step is initial setup. We start with two boundaries. Low is 0, the first index, and then high is 5, the last index, since there are 6 elements. Now, to decide where to look, we calculate the middle index. With the formula, mid is low plus high div 2, which is low is 0 and then high is 5. So 0 plus 5 div 2 is 2. This means we check the elements at index 2, which is 7. And then the second step is compare mid with target. The target is 15, and then the middle element we just found is 7. Since 7 more than 15, our target must be on the right half of the array. So we move to lower boundary up. With the formula low is mid plus 1. So mid is 2, and then 2 plus 1 is 3. Now, the third step is recalculate mid. Now, the new boundaries are low is 3 and then high is 5. Calculate the new middle index. With the formula, mid is low plus high div 2, which is low is 3 and then high is 5. So 3 plus 5 div 2 is 4. So we can check the element at index 4, which is 15. And the last step is found the target. The element at index 4 is exactly our target, 15. So therefore, the search is complete. So we can say the value 15 is found successfully at index 4. But guys, you just to remember that binary search always works by cutting the search space in half. Instead of checking each element one by one like in sequential search, we jump directly to the middle, compare, and then decide whether to go left or right. This makes it much faster, especially for large arrays.
Alright, let me introduce myself. My name is Daflawan Aziz with assistant code DNA, and now I'm gonna explain the example of binary search program. As we all know that in program we need library to support, and here I use stdio.h and string.h. But guys, this string.h is a miss, and actually we don't really use it, so we can run it without the library, without the string.h library, or skip it. Okay, in here we have variable declaration to support the program, and the user must to input how much data that user want. And for the example, the user put the number of data is 5. And after that, we have variable declaration again to support the binary search. And here we have low that have value is 0, and variable height that have value is how much data minus 1. And here we have the user must to input the number for each data. In this case, we have 5 data, and this 5 data is empty. So the user must to put the number inside it. In here, the first data is 7, the second data is 5, and the third data is 9, the fourth data is 1, and the fifth data is 3. And we have sorting process in this program, because in binary search we must to sort before the binary search program. Okay, because the binary search have the logic that in the left is a small number and the right is the largest number because we have middle variable to support it. Okay, I will explain it later. Okay, after the process of sorting number from smallest to largest, or usually we call it ascending. Okay, and after that, the user must to input the number the user want to search for. Okay, in this case, the user want to search the number is 9. Okay, next. After that, the binary search process is doing. First, we have while logic that while low is smaller than value from variable height, the binary search is ongoing. In here that I explained before, we have variable to support the binary search. The name is mid, and the value from mid is low, the variable value low plus variable value hike and divided by 2. As we all know that low is 0 and high is how much data, and this example the data is 5. Because high is how much data minus 1, the data is from 5 to minus 1 and then gonna be 4 and divided by 2. So after we sorting the data, it's gonna be 1, 3, 5, 7, 9. Okay. Because the mid is 4. It's a 4 divided by 2. Mid is gonna be here. Why the mid is here? Because mid is follow the index number. Yes, I know we have 5 number, but the real index is 0, 1, 2, 3, 4. So actually we have for the data index because it's 2, the mid is in here in data value 5. And because low is 0 is gonna be here, and the height is how much data minus 1. In this example, how much the data is 5 and minus 1. So the height is here because the 9 in here is have index 4, right? 0, 1, 2, 3, 4. So height in here. After that, if the index number mid, which is 5, is same like we search for, which is 9, and the middle index is 5, it's false. And if the number in mid is larger or smaller than we search for, which is 9, it's gonna be have some small searching to search the number we gonna search. In this case is height is gonna be mid minus 1. So the height in here is gonna be mid minus 1. So the height is gonna be here. Okay. And after that, the middle or mid is gonna be follow the low and high, because in here low plus high. So low is 0 and high is 1. So 0 plus 1 is 1, and divided by 2 is gonna be 0.5, right? But we're gonna make it 1 to follow the height. So the middle is gonna be here, right? And another case, if for example the user want to find 5. Okay. Sorry, this is miss. Just want to search 5, sorry. Because the mid is here and the index in mid is have value 5 and we want to search 5 and the number is same, it's gonna be have output here and data found at index 2 because in index here we have 0 1 2. Yep, because it's same like we search for, it's gonna be in index 2. Okay, I'm sorry, this is I have missed to explain. It must be not no. It's not gonna be 2, but it must be 4. Yeah, it must be 4 because 0 1 2 3 4. Okay, in another case in here else if in this case the number of mid is larger than we gonna search. Oh, I'm sorry, it's bigger than we gonna search. In here mid and we gonna search 3, for example, yeah. This is low, this is high. It's gonna be smaller searching and change value from low, and low gonna be mid plus 1. So low in gonna be mid plus 1, which is the low is gonna be here. And of course the mid is follow the change because mid is follow the low plus high, so it's gonna be changed too. The mid in here low we have value is 0 1 2 3 3 plus height 4, which is 0. 0 divided by 2 is 3.5, right? But we gonna make it simple and follow the low to be 3. So the mid is here, and after that the mid is same like we searched for, which is sorry, the number of data what we gonna find is 0. Is same 0 and 0, and then we find it at index 3, just like that. And this program is when the data is not found, the program will produce this output, data not found. And there you go. Then maybe just that for me, and thank you and see you next time.
Okay, next, I will explain the flowchart of the binary search. First one, after the program start, we will declare the variable. And this one, in this program, there are data, found, number, temp, mid, and valid. And after that, it will continue to the input that we can enter on how much data that we want to share. And there will be another declaration, so we can declaration the integer low equals to 0 and the integer high equals to data minus 1. After that, there will be another decision, and this part is also the loop part that we can enter the number for each data, and after that it will you can enter the number that you want to search for. After that, the program will start to sort and search. So there will be another decision, and this will compare the value of number A. Is it bigger than number J? If yes, then they will swap each other. They will swap the value of each other, and then the program will set mid equals to low plus high divided by 2. After that, there will be another decision. Is the value of angka on the position of mid is as expected that we want to search? If yes, then the program will set the valid variable equals to 1, and then if it false, there will be another decision. Is angka is the value of angka on mid position is bigger than the variable found? If it's true, then the program will set the low equals to mid plus 1, and then high equals to mid minus 1. And then after that, it will start to the first decision again. If on this first decision is false, it will continue to another decision. So is valid equals to 1. If it's true, then that means the data is already found. But if it's false, the data is not found yet. And then that means the program is already over.